Right, now that you have decided that you would like to reduce the dimensions of the construct or reduce the number of variables in your dataset, and you're trying to decide which technique to use, the principal components analysis or exploratory factor analysis. To do so, you need to understand principal components analysis and exploratory factor analysis quite naturally, but there are some differences and some similarities between the two assumptions that I will discuss in particular in this lecture. So, both of the analyses are making the same assumption, and that is that any sequence of n numbers can also be considered to represent n-dimensional space. So now looking at your data table, what you have is rows representing the observations, and you have the columns describing the attributes of those observations. If you start looking at the patterns of the correlations between these different attributes or these different variables, you will realize that some variables are highly correlated with each other, and some variables are not as highly correlated with each other. So what you will be saying now is that some dimensions are closer to each other than others based on your correlation matrix. The variables that are more highly correlated with each other are likely going to be representing the same constructs or the same higher order dimension that is going to be a permutation of your lower order dimensions. So how do you identify the higher order dimensions without simply looking at the correlation matrix and making a guess? So here's where PCA and EFA come in especially handy. So let's take a look at a very simple example. Suppose you have a simple data set with 6 variables. 5 of those variables you think are going to be describing the social skills abilities. So that is going to be describing the teaching skills, the social anxiety skills, presentation skills, communication skills, and nonverbal behavior. And somehow we ended up with having the eating pizza as one of our social skills. And what we want to do is identify whether eating pizza is actually a part of the components for the social skills or a factor for social skills, and whether the other 5 variables are actually heading together quite well. So PCA and EFA are going to be approaching this problem quite differently. In PCA, what the PCA will do, it will take a look at the correlation matrix, identify the high correlation, and if the correlations between the different variables are high enough, it will suggest that you group the variables into a single component. Naturally, you can imagine that eating pizza is not going to be highly correlated with any one of the teaching skills, social anxiety, presentation, communication, or nonverbal skills, and hence this variable will be dropped and will represent likely a very separate component. So that is in PCA, you're analyzing the total variance in the matrix, and you're looking at the correlations that are high enough to warrant inclusion in the component. EFA makes a very interesting assumption on the other hand. It makes an assumption that there is an underlying latent hypothetical factor that you have not measured and that can describe all of the variables in your data set, or most of the variables as in this case. So here it will focus on the common variance between teaching skills, social anxiety, presentation skills, communication skills, and nonverbal behavior, saying that the common variables represents this huge factor that has not been measured, social skills, and that social skills are causing an individual to have either good or bad presentation skills, either good or bad communication skills, and so on and so forth. Hence, you see the direction of the arrows pointing towards the measured variables. So what you're saying is that some underlying disposition of an individual is likely going to cause how they are going to be behaving in the real world or how they're going to be responding to items. Here you see a dashed line leading to pizza, and that basically suggests that social skills are not likely to cause an individual to eat pizza. So quite naturally, you can imagine that individuals with high social skills do not necessarily eat more or less pizza or like pizza more or less in comparison to individuals with low social skills. So that is, social skills are probably not going to be well estimated by including the eats pizza variable in the data set. So there's some commonalities between PCA and EFA, but there are some differences. And if we take a look at the PCA and EFA, and in particular differences between the two, PCA it considers the total variance within the matrix, whereas EFA explains the common variance, so that is the communality between different variables. PCA also identifies measures that are sufficiently similar to each other to justify combination, whereas EFA captures latent constructs assumed to cause the variance. So the cause assumption is completely theoretical in here. And what we're saying here is that there is common variance between the variables, and all of the measured variables are going to be caused by this underlying construct. In most behavioral sciences, and especially survey research, EFA is an especially pronounced analysis that is often utilized by a number of scientists. However, principal components analysis can also be quite useful, both in behavioral research and otherwise. For example, when we're looking at the faces that contain a number of attributes, so say eyes, the eyebrows, the eyelashes, and the nose, we cannot necessarily say that the upper part of the face is causing the eyes to be in a certain way, or it is causing the eyebrows to be in a certain way. Hence, we are more likely to consider the upper part of the face to be a component rather than a factor that causes the measured variables. So finally, some definitions that we need to know that will come in useful, especially once we start interpreting the output, is the loading, so the correlation between each variable, so each dimension that you have, and a larger component or a factor. The communality, or the amount of variance of each variable explained by the factor structure, so suppose you have 2 or 3 factors, and what you're going to be saying is that the variable is in part going to be related to each one of those factors. And finally, the uniqueness, or the amount of variance in each variable not explained by the factor structure, or 1 minus communality. Uniqueness is especially relevant to the factor analysis, which considers the measurement error, whereas the PCA very often drops the measurement error from equation altogether.